In this video, we're going to start talking about object-oriented programming, and in particular about classes, which is a fundamental component of object-oriented programming in Java and actually other languages for that matter. So firstly, we need to understand what objects are. They really are the key to understanding this object-oriented terminology and technology as such. So what I'd like you to do is just have a look around in the room or the area that you're sitting at right now. And if you do that, you'll find that there's many examples of real-world objects. For example, I'm sitting here and I can see a computer, I can see a keyboard, I can see a microphone, I can see shelves on the wall, I can see a door. All of these are examples of real-world objects. And I'm sure if you look around wherever you are, you can see a number of those as well. Now, real-world objects have two major characteristics: the state and behavior. So state in terms of a computer might be the amount of RAM it has, the operating system it's running, the hard drive size, the size of the monitor, those types of things. An ant, for that matter, has got state as well. For an ant, the state might be the age, the number of legs, the conscious state, whether the ant is sleeping or is awake. But looking at behavior for a computer might be booting up, shutting down, beeping or outputting some form of sound, printing something, drawing something on the screen, and so on. All of those are behaviors for a computer. For an ant, behavior might be eating, drinking, fighting, carrying food, those types of things. Now, software objects, which are a fundamental part of object-oriented programming, they're very similar to real-world objects because they also consist of state and behaviors. Now, a software object stores its state in fields, and we know fields as variables, and they expose their behavior with methods, which we've talked about before. So that's what an object is in object-oriented programming terms. So where does a class fit in? Well, think of a class as a template or a blueprint for creating objects. So as it turns out, you've been using classes all along, and I'm sure that you've seen the keywords public and class in the code we've completed to date, and you can actually see that on the screen right now, public class main. So what that is, that's actually a statement which creates a new class in Java. So a question that might come up at this point is, why do we need to bother about classes? What benefit do classes give us in our everyday programming? Well, think back to the basic data types we've worked on, the primitive data types that we've explored so far, int, shorts and those types of things. They're all basic data types, but they are fairly limiting. There's only so much you can do with them. So a case could be made here that a class can be thought of as a powerful user-defined data type, sort of an extra data type. That's not really correct in the true meaning, but it gives you an idea of what classes are. They really enable you to have sort of a very powerful user-defined type where you can create something way more powerful than a regular primitive type like you've been dealing with in the past. A regular data type on steroids, if you will. So to take this a little bit further, let's create our first real class. As you can see on the screen, every time we create a new project, it actually creates a new class for us, and it calls the class main with a capital M, and it also creates that method, the lowercase m for the method name. That's created automatically by IntelliJ when we create a new project, but let's actually go ahead and create a brand new class ourselves. So to do that, we need to make sure the project area is open. We click on here to open that up. Click on down where it's got SRC for source. We want to select where it's got our package name. Click on that, right click, select new, select Java class, and we're going to create a class with the name of car, C-A-R, making sure the first letter is capitalized. As is recommended when you're creating classes in Java, the first letter should be an uppercase letter. But I will be talking more about naming conventions for classes and variables actually in a later video in this course. So firstly, what I want you to notice is the package. You've seen that before at the top, but also check out this line, this public class car. So that's actually the statement to create a new class with the name car. Now, incidentally, if you want to see what's happening behind the scenes, you can come over here and you can right click car. And on my Mac, I can click on reveal in Finder. If you run a Windows machine, I think the equivalent command is show in Explorer. When you click on and do that, what it does, it shows you the directory and also shows you the files that are in that directory. And as you can see here, IntelliJ has automatically created a file called car.java, and it's in the folder Tim Bachauka. Now, if I actually open that out, the top there you can see classes is the name of the project that I assigned. Then there's an SRC folder, which stands for source. And looking on the left-hand side, you can see in the project view, you can see that that's showing you that's SRC as well. Then it's created another folder called COM, and then another subfolder of COM called Timberchalka. And that's how packages work in Java. So you can see that we've got a folder. Whatever you type with a dot, that's a subfolder of that name is automatically created by IntelliJ. So what's happened here is that IntelliJ has created this file, car.java, and that is a Java source code file. And every time you create a new class, this is what's happening behind the scenes. It's creating that class in a particular folder. Now we can open that up and have a look at it. And if I go into the Mac text editor, we can see it mirrors exactly what we've got in IntelliJ. So it's always a good idea to know what's happening behind the scenes when something is created in IntelliJ. And invariably, when we're dealing with a file, it's creating a file in that particular folder. All right, so moving on. So public and class, as well as package for that matter, are all Java keywords. Now the public keyword is an access modifier that we use here to determine what access we want to allow others to have to this new class that we're creating. So the word public means unrestricted access to the class. Now usually, and at least initially anyway, you're going to be using public for pretty well all your classes, but other access modifiers we can use include private, and that's where no other class can access that class. Protected, which allows classes in this package to access your class, and you can also remove the access modifier completely if you prefer, but we'll be talking more about what these access modifiers are in future videos. For now, generally speaking, just go with the word public, knowing that that means that other classes that we create have got access to this class without being restricted. So that's our class defined, but at the moment it's not very useful because it doesn't actually do anything. Literally, we've created a shell. It's like creating a new blueprint. So remembering that a class is a blueprint for an object that we're going to be creating. And in this case, it's like virtually, starting out on a brand new blueprint, and we haven't done anything yet. We've just, we literally, if we were creating a blueprint for a house, this is page 1. We've called the blueprint the name car, and we haven't done anything else at this stage. So what we need to do is create some variables that are part of this class. Now to date, you've seen variables used inside a method, and they were called local variables because they're local to or actually belong to that method. And you cannot access those local variables outside of that method. And you saw that also with code blocks that we created in past videos. Once you access that, you cannot access those variables outside of that block. Now classes allow us to create variables that can be seen and are accessible from anywhere within the class that we're creating. Now these are known as class or member variables, but most commonly you refer to them as fields. Now when you're creating a field for a class, you need to also specify an access modifier that works the same way as the access modifier for a class definition did. Now, as a general rule, when you're defining fields in Java in a class, you go with the access modifier of private, unlike the class where we've gone with public. So what private means when talking about fields is what we're really doing with it is we're adhering to encapsulation, which is a key fundamental rule of object-oriented programming. So encapsulation in Java is used to hide the fields and methods, which we'll see later, from access publicly. So it really means that the internal representation of an object is going to be hidden from view outside of the object's definition. So in other words, the internal workings of the particular object, and again, an object is going to be created from our template, from our class. So what we're doing is we're only allowing the internals to be accessed by this class or by this object. We're not allowing outside access to that. Now this will make more sense as the video progresses. So what we're going to do first is we're going to create some fields for our class. So let's get started and do that. So what we need to do is so I've just gone into the curly braces within the car class. So we need to type private int doors. So notice how I've typed the word private. In the past, when we've created variables, we haven't needed to do that. We've just actually typed the data type and the name of the variable. In this case, we also need to add that access modifier. So generally, you will always go with private, and I'll explain more as we go through. So these variables are actually the state component for a car. So these are characteristics of a car, if you will. So we're going to have doors, how many doors it's got. And let's go with, say, the number of wheels. It'll be an int as well. And let's go with the model. And we're going to go with a string there, so we can just type freeform text for what the model is. And let's say we do the same with engine. And let's finish off with color. So what we're trying to create here is a template of the variables that would be part and parcel of a car. Now obviously if we're creating a real application, there'd be a lot more fields. There could literally be hundreds of different fields that we could add for a car. We're just keeping it simplistic to start with. So this is the state component when we talked about state and behaviors. This is the state of the car, if you will, which we're defining as fields. So what we've done there is we created a very basic class and we've defined 5 fields. So the next thing we need to do is we need to create an object from this class, because if you recall, the class is just the template, but we need to create an object which will sort of take that blueprint, that definition that we've defined in the class, and create an object that we can start using. So to do that, what we need to do is we need to go back to the main class, and of course the main class was created automatically by IntelliJ when we created a new project. I'm going to double click into that over here on the left. Now what we can do in here is we can actually build an object and base it on that car. So what we now need to do is create that object. So how do we do that? Well, what we do is, well, I'll delete this code for starters. We're in a method now, so we're going to type a local variable that's local to the main method, as you can see in here. And we type car. Now notice when I type car, it's come up with com.timberchalker.car, so it knows that this car has been defined over here. So as far as Java is concerned, that is now a data type. It's actually a class, but we can treat it as a data type. So we can type car, and let's create our first object, and let's create a car that I've always loved, which is a Porsche. Porsche. So this is the keyword. This is how we define an object of type car, and we call it Porsche. Now the other thing you need to do is when you're creating a new class, you need to initialize it. So to do that, instead of just leaving it like that, we need to type equals new and car. And I'll press enter there. And notice how the 2 brackets were automatically added by IntelliJ and put his semicolon there. So what we've done there is we've created a new data type called Porsche, which is of type car. So in other words, we've created an object called Porsche based on the template car. So that's one individual object that we can work on. We can also create another one. We could do car Holden. Holden is an Australian brand car, so we could do the same, equals new car. So we've now got 2 separate objects that we've created from the template from the main class called car. Now the thing is, we can't do much with those as yet. So for example, how do we go about accessing the state variables, the fields in other words? Now just by that definition, what's happened behind the scenes is the object has been created, but there's also extra functionality that Java has added to these objects for us automatically. And to see that in action, we can type Porsche. And if we type dot, now all these things here are actually variables or methods that are accessible from the class from this object. Now you might be thinking, well, what's this equals, hash code to string, etc.? These are added automatically by Java whenever we create a new object. So you could say that they're inherited from the Java functionality when we created the car. So to be correct, what's happened is the car class has inherited these from a base Java class. But we'll talk about subclassing and those types of things later. It's probably not the time to do that now because we're starting with the basics. The bottom line here is Java has added all this code and this functionality automatically. And you're also free to add extra things, which we'll be doing shortly as we move forward anyway. My point is, at the moment though, if we look at the list of things that are available, you can see that these equals class and so forth. But if you scroll down and have a look, there's different keywords and so forth, but we don't see anywhere our model, the number of wheels and so forth. It's not showing up there. So how do we access those? Well, if we go back and check out the car class again, remember we defined these all as type private. And what private means is don't allow a class outside of the car class to access these variables. If you wanted those to be accessible outside of the car Java class, we could do that by changing this access modifier to say public. So I'll just change the model. And if we go back and check this out now, And now if we go back and put a dot in there, you can suddenly see that the first thing that appears now is model. So suddenly model has actually appeared. So at that point we could type Porsche.model equals the Carrera. Hope I've spelled that right. So what we've defined is for our object Porsche, we've told it that the model, remember the model is the field, which is the state, if you like, for the car. Porsche.model equals Carrera. So we've defined the type. Now that's one way of accessing the data, but it's not actually a good way because it really more or less violates the rules of encapsulation. Because what we should be doing is making sure that that functionality is restricted and placed in the car Java class. What do I mean by that? Well, let's go back and I'll just show you what I mean. So we'll go back to car.java. We'll change that back to a private again. But what we'll do is we'll create a method now. So we're going to create a method, and when you're in a class, when you create a method, that is then attached to all the objects that you create for that particular class. Now in the past, the only methods that we've created are static classes, and static classes aren't really the same thing, but we'll be talking more about those later. For now, let's create a public method. Okay, so this video is getting a bit long, so I'm going to pause here and we'll come back in part 2 and continue with our discussion of classes.